Hello friends, welcome to Electronic Circuit Hub. So today we are going to understand about the temperature sweep analysis of 2.5 volt shunt regulator. Let us say you have designed one shunt regulator and you want to understand the the shunt regulator performance with respect to temperature. Let's say your operating temperature or your ambient temperature is minus 55 to 125 degrees centigrade, and you want to understand how my shunt regulator is going to behave if I change the temperature from minus 55 to plus 125. So in nutshell, you want to understand what is the impact on your output voltage, what is the impact on your output voltage regulation. So if you have the change in the temperature which is negative minus 55 to 125, and how your shunt regulator behaves with respect to the temperature. So in order to understand the temperature behavior of your 2.5 volt shunt regulator, you need to understand and run the temperature sweep analysis in LTSpice. And how you're gonna run the temperature sweep analysis, and how your output voltage is impacting, we are going to understand this all things in today's video. Okay, so before I run the temperature sweep analysis, let us first understand basic how the circuit works and what is the output of your 2.5 volt shunt regulator, right? So if you come back now this side, so I have the simple 2.5 volt shunt regulator, the same circuitry I'm using there. I removed the DC analysis, the temperature sweep analysis. What I'm gonna do here is I'm gonna run simple the transient analysis, and let us see what is your output of your, if you don't have the temperature impact, what is the output of your 2.5 volt shunt regulator. So how this circuit works is, this is the 5 volt input and I have the current limiting resistor which is R4, and the value of R4 is 3.6k. Then I have the U2 and which is LT1009, and this is again 10k and 10k, which is giving the stable output reference which is 2.5 volt. Okay, so now I'm gonna run the simulation, and let's say I'm gonna run the transient analysis, and let's say what is the output, what is the input, and later I'll run the temperature sweep and we'll understand what is the impact of your temperature at the output. Okay, so in order to run the transient analysis, you have to go simulate, edit simulation command, and I'm doing the transient analysis. So I'll click on the transient analysis. My stop time is 100 millisecond. Click it OK, and now I'm gonna run the transient analysis. So run it. So if you run it now, what I'm gonna show you the input and output both. Okay, so what is your input? If you look at here, your input is 5 volt, exactly 5 volt. And what is your output? If I add one more plot pane, my output is, how much output is? It is exactly around 2.500. Okay, so in this case my input is 5 volt and my output is 2.5 volt. You can clearly see how you can design 2.5 volt stable shunt regulator. Okay, that is how by using LT1009 you can generate a stable shunt regulator output. Okay, so I would like to thanks to the linear technology for providing the LTSpice, very beautiful tool, and providing these simulations in LTSpice. Okay, so it is very useful. You can also try understanding the circuit, try using the LTSpice. And LTSpice, if you talk about the analog and electronics, you can simulate anything in LTSpice. Okay, so now your input is 5 volt and the output is 2.5 volt. So what now I'm gonna do is I'm gonna run the temperature sweep analysis. So in order to run the temperature sweep analysis, what you want to do is you have to disable your transient analysis. In order to disable the transient analysis, you just mark it as a semicolon. So now you can see I have the semicolon. That means the simulation is not going to run now the transient analysis. And I want to run now the temperature sweep analysis. So in order to run the temperature sweep analysis, I have to disable the semicolon from here, and maybe I'll put the dot, and I also have to disable the semicolon from this. Okay, now how you gonna run the temperature sweep analysis? So what I'm doing is, again you have to go at simulate. Okay, go at simulate, edit simulation command, and go at now this time DC sweep analysis. And the type of sweep you gonna do is temperature sweep type. The nature of first source to sweep is temperature. The type of sweep is linear. The temperature value is varying from minus 55 degrees centigrade to plus 125 degrees centigrade with the increment of zero point 0.1 degree centigrade. That is how the temperature sweep. Okay, you can write the command. And what I am also doing is I am changing the resistance value by using the stepping parameter. So let us now run the simulation and let's see the behavior of output if you are changing the temperature from minus 55 to plus 155 degree centigrade. So what I'm gonna do is, again I'll go run button, click the run button, and let us see. So go at window, tile window vertically. Now let us see the input first. So your input is 5 volt, exact 5 volt. Now let us see the output. Okay, so this is your output, right? This is your output. And now if you look at your output, if you have the temperature sweep that is from minus 55 to plus 125 degrees centigrade, and if you look at in this here, the x-axis, my temperature is sweeping from minus 55 degree to plus 125 degree, and in the y-axis you can see the shunt regulator output, that is it has to be 2.5 volt, very stable. But if you look at now, it is changing. If you're changing the temperature, it is changing at 25 degree. I see it is around 2.47, and it is changing from 2.47 volt to 2.49, almost 2.5949 volt. So that is how you can simulate the behavior of your reference or shunt regulator, how it is behaving if you have the change in temperature in your design. And if you want to design your product from certain temperature range to certain temperature range, you need to understand the the behavior of your components, behavior of your, in this case, shunt regulator output with respect to the change in the temperature. Okay, so that is how you can simulate it. You can design and you can simulate, and you can run the temperature sweep analysis. It's very simple to run the temperature sweep analysis, and you can analyze the output of your shunt regulator, 2.5 volt shunt regulator. It is, if the first I ran this simulation, wherein we found that the output was 2.5 volt. Then I ran this simulation and I ran the temperature analysis. Now I see the output is changing from 2.47 volt to 2.495 volt. Okay, so you have the impact of your temperature in your shunt regulator in your 2.5 volt reference IC. Okay, that is how you can simulate and you can understand the behavior of your shunt regulator. So hope guys you understand how you're gonna design the shunt regulator, how you're gonna run the temperature sweep analysis. If you have further doubt, feel free to ask me in comment section. Thanks for watching this video.